Hello everyone, welcome to System Admin World. Today we are going to discuss about the AWS DynamoDB, how it can be help us to implement the remote state locking system for the Terraform using the remote backend with the S3 bucket, AWS S3 bucket. Okay. So before going in the practical, I just want to make sure you are aware about how the state file works. So take an example, developer 1, developer 2 and developer 3 wants to deploy the EC2 instance and work with the one single EC2 instance and update or the configure or change the configuration like tagging or like IP addresses or any other configuration related to the S3 EC2 instances using the Terraform. So local state file configuration in the Terraform, how it will work. So it's consider developer 1 trying to deploy the EC2 instance on the AWS cloud and using the Terraform. So he will be create the configuration on his local system or local working folder, and from there once he applied that configurations to the AWS cloud, so it will be create a local state file on his local system where he is trying to deploy the configurations. Okay, so that purely stored on his own developer 1 local system. It will be not accessible by any other developer 2 or developer 3, and there it's problem where a statement comes up and where if he or she from developer 1 or 2 wants to do any changes on the same EC2 instance using the same state file from the Terraform, they cannot do because they don't have access to computer 1 and the Terraform state file which is deployed by the developer 1. Okay, so to avoid or come up with a solution for this problem statement, so there is a provision and configuration setup provided by the Terraform which is called the remote backend state file. Okay, so remote backend, so you can set up. So you can use the S3 bucket as a remote backend. What will happen once you use the S3 bucket? So the all state file deployment and configuration changes will be stored in the S3 bucket as a shared folder, and it can be accessed by the developer 2 or developer 3 also, even it is deployed by the developer 1. Okay, so once the developer 1 do any changes, it will be deployed in the EC2 instance, whatever changes he pushed through the Terraform using the same state file configuration. But the developer 2 also can be deployed. But what happened here? So another problem occurs here whenever developer 1 and developer 2 trying to deploy the configuration on the same EC2 instance using same TF state file. So then it conflict can be occurs and it can be falls into corruption of the TF state file, or it can be destroy the TF state file. So to avoid that conflict, there is a custom solution can be implemented using the AWS DynamoDB to store the state locking file. So this third slide will be explain how the TF state file can be locked, or how the remote backend state file locking can be implemented using AWS DynamoDB. Okay, so where the scenario when the developer 1 try to do any changes on the EC2 instance, and the same time if developer 2 wants to do the changes, so whenever the developer 1 execute the TF state changes using the Terraform apply command, so the same time it will be create a lock and key and stored in the DynamoDB, and that will be considered by the developer 2 when he same time if he is trying to deploy any changes to EC2 instance using the Terraform with the same TF state file, that it will be refer the DynamoDB key table. So if the key is available and someone locked out, he will be get message on the screen so that developer 1 is already locked the file on the using DynamoDB on the TF state file which he is trying to make any changes. Okay, so until developer 1 not release the key or release the state file, unlock the state file by his deployment or update, so developer 2 cannot do anything. Basically it will be block the access to do any changes on the while developer 1 is doing any change. So the similar happened for the developer 2. Unless one developer not deployed or complete his changes, it will be not going to be allow another changes to be implemented by any other user. Okay, so let's see how we are going to deploy these changes using the Terraform configuration. okay, how the backend can be set up and how this DynamoDB can be help us. Okay, so today we are going to use the S3 bucket. So we are going to create S3 bucket from scratch, okay, and then create a DynamoDB table on the DynamoDB service, and then will see the demo how we can get the state file lock using the DynamoDB. Okay, so let's jump into the our code platform, which is Visual Studio Code I'm using, and you open the terminal. I divided this code in 3 different sections, creating the S3 bucket first, then we'll create a DynamoDB, and then implement the backend for the developer 1 and developer 2. So okay, so I'm not using the 2 different systems here. Only I created 2 different tables with the same configuration, which will be shared the remote backend state file. Okay, so the first scenario, we are going to create our S3 bucket. Okay, so which is name is sumit-terraform.state on the AWS. Okay, so let's start doing that. So I will go backend on the root folder. Okay, so DynamoDB Terraform, it's a working folder, my working folder. So let's go into the create S3 bucket folder. Okay, so here I will run the Terraform init command to get the initialize the configuration. Okay, so now the initialization has been done, and now I'm going to implement the type the command to execute the Terraform plan. It will be show the plan. Always good practice to, before Terraform apply, you should execute the Terraform plan to make sure the whatever changes you are going to do, it will be appears as is what you require, or it will be validate any error or anything before deploying. Okay, so Terraform apply has been executed. So if you see that there is a 5 component going to get create, so which will be I have a lot of configuration doing around blocking your public access and everything, and implementing the SSS algorithm. So these all configuration I applied. That's why it is 5 components going to be applied once it is execute the S3 bucket creation. So we'll simply go Terraform apply. So wait for a minute. Okay, it will ask your authorizations. I type yes. So S3 bucket is getting created. Okay, and now it is successfully created. Okay, so now same way we will go back to our another script, where we can create the DynamoDB table. Okay, so if you see here, if you see this output, the Terraform has created the new S3 bucket, which is sumit-terraform.step. I use the output configuration, which will give all the information about the Terraform S3 bucket. Okay, so the second configuration I am using to create a DynamoDB using Terraform. So I'm using my provider and the profile. I created the profile for my key. Okay, and then resource I'm creating the Terraform. So the Terraform table name is tf-state log DynamoDB dynamo. Okay, the hash key I'm using lock ID. So read capacity and write capacity I kept 2020. Okay, and attribute I'm creating the name attribute is lock ID, and then type will be the S. Okay, the string. Okay, so type will be the string. Now let's go into folder where, let's clear this screen. So I am in now create DynamoDB folder. Here also we need to do the Terraform init. I purposely did this separate folders. You can combine both S3 bucket and DynamoDB all together in one state file. It will not going to be harm. okay, but make sure it will be aligned with your configuration. So to show how we can create a DynamoDB using Terraform and how you can using the S3 bucket, I split this. Okay, so now the initialization has been done. So we'll be do always Terraform plan. Okay, you can see the Terraform plan will going to create your table named the TF state lock dynamo and 20 records write capacity. The attributes I'm creating lock ID, which is string type. Okay, so now our setup is ready. We now created the S3 bucket and Dynamo table. Let's go quickly and verify once whether it's created or not. Okay, I'll just go and refresh. If you see here, we have created the S3 bucket. Okay, now let's go back. Check whether it's created. Okay. So now just apply after plan. Okay. If I apply, so it will be create DynamoDB. So give the permission yes. So DynamoDB table is getting created. So apply completed. So one table created. Let's go back and review again whether it's created or not. So if you refresh here, so TF state log dynamo table is created now. The provision 20. It's not on demand, it's provision based. 20 we created. Okay, so let's go back to again our terminal, so where we can see how the state file can be held. Okay, so let me check now. Let's go back a little bit. Okay, so now what I did here, I created two different folder where it's developer 1 and developer 2. Okay, so let's clear this. cd 01 03 Terraform, sorry, 03 backend. Okay, so now we are in two different folder, like a developer 1 and developer 2 folder. So now we are going to do actual thing and check how the Terraform backend will be work. So I have created one small config file where the Terraform will be trying to deploy the EC2 instance using the backend. So this is the backend configuration. So where I have mentioned the which backend has to use. It's a S3 backend I have to use, and use the S3 bucket which I created, and use the terraform.tf state file store in the backend. The region is 2, and using to store the lock key, I am using the DynamoDB table, which is TF state lock DynamoDB, which we created. Okay, then I'm trying to create the EC2 instance from dev 1 and dev 2 also. So if you go here also, you can see the same configuration I'm trying to achieve here. Okay, so let's go one by one. Okay, so first we will be trying to initialize the configuration for the developer 1 in the folder developer 1. Okay, so whenever you do the initialization, only one small thing I want to note here. So developer 1 or developer 2, even you initialize the Terraform init previously before deploying your remote state or the backend, remote backend. So you have to initialize again to acquire that remote backend configuration or transform your local Terraform state file if you created previously to the remote backend. Okay, so how we can do that? We can execute the Terraform init command on the developer01 folder. Oh, sorry, so I have to mention the specific command. I'm here. So why I need to do this, I'll just explain you. So whenever I'm running the Terraform, I'm using the profile. Okay, so profile needs to explicitly mention in the command which profile I need to pick up to initialize the remote backend configuration. Okay, so I can mention this configuration in the backend itself. Profile is equal to Terraform. Okay, but I'm just explicitly trying to show you here how we can use it using the command itself. Okay, so if you can execute, sorry, need to complete the custom. Yeah, so starting initializes backend. If you can see here, it will be trying to initialize the remote backend, even the configuration done. So okay, so it's initializing the HashiCorp init command initialization done successfully. And now it's having the backend available, and the same command we are going to execute here. So on developer02. So this is the developer02. Okay, I'm trying to execute the same command here. So initialize the backend and the developer02 also. If you see, it is showing initializing backend. Okay, so here it's created Terraform and transfer the file to the Terraform backend, and here is 02 now trying to initialize the backend. Okay, so this is the connection, initialize the backend and accessing the Terraform from the S3 bucket. Okay, in this on developer1, it has been created and initialized to S3 bucket. The Terraform state file will be created during the 01 developer01, and now it is available for 02 also. Initialize the backend and get configuration. Okay, so now the next command is just clear the screen. Okay, now what I am going to do, I am going to check that Terraform plan whether this configuration is okay. So it is trying to create a new deploy one new configuration. Plan is working fine. Okay, so now what I'll do, I'll try to apply this configuration on developer01. Okay, Terraform. Okay, so I'm on 01 developer1. I am trying to apply the configuration. Okay, so 01 developer, apply the configuration. Now it's trying to create a one EC2 instance with all the configuration we provided the requirement. And if you see here, it is asking for authorizations. We are not going to authorize this now. Let's see the another configuration here. Go back to the S3 bucket, DynamoDB table and S3 bucket to verify whether our log file is created or not. Okay, so let's see here. Okay, if you can see, this is log ID submit underscore terraform that terraform.tf state has been created the log ID. Okay, the log information is here, and if you go back, is locked out, the log new created, and if you go back in the code level, if you terminal, if you can see, it is stuck in the entry value. So if same time the developer2 came up, okay, and he is trying to just squeeze the, okay, he is trying to also apply. Okay, so if you see here what it is saying, so it is giving error acquiring the state lock. Okay, so it is trying to acquire the state lock, but the acquiring state lock is failed. Okay, conditional. Why it is state lock? So lock information it has provided. What is the lock ID currently applied by the developer 01, and because of that this is the path, the state file. This is the S3 bucket. It is showing S3 bucket where the state file is going to be locked, and operational is apply. It's applying state operation, and the version 1.5.1. okay, so the current date it is showing when it is trying to log the system. So there is an option given. If you want to override that, you can use the lock _ false. So but this will be false, not recommended, and it will be going to destroy or corrupt your file. Okay, so this is not at all recommended. So let's go and do the reverse. Okay, I'll go back for here and say no. Okay, and now it will be apply cancel. Okay, let's see if it's again give the lock. So developer 2 should now, okay, so now he is trying to, so Terraform is trying to perform. So if you see here, after apply, it is trying to acquire the lock state, and now developer 2 has been put the lock on that tf state file, and that way developer 1 should not be able to write a file now. So let's see what will happen if a developer 1 trying to update that file. Okay, the same message now developer 1 is getting, while the developer 2 is trying to deploy the configuration. At the same time developer 1 is deploying, or like 2 is deploying. Okay, so it's failing the state lock. So it is giving the who is locked out the state, and what time and which folder, what is the part Terraform backend point state file. Still now let's go and apply by the, while from the 02 user. So yes. Okay, so instance is going to be create. It's creating. Just go back in the S3 bucket and see whether the file is creating or not. So go back to S3 bucket. S3 bucket name is made tf state. Still, so enable the versioning. Yeah. If you see here, so that terraform.tf state is file created. Okay, and now showing here. Let's go back in the command line, check whether, yeah, so it successfully apply one configuration. Okay, and it will be completed. So let's go back. By now in S3 bucket, what's happening we can check. S3 bucket, and then let's check on the DynamoDB what's going on. DB table, tf state file, and the explorer table. Back on the developer 1 and try. Let's check whether EC2 instance is created or not. Yeah, you can see one EC2 instance is created now. Okay, successfully. And if you see the tags, this is the developer tag. Okay, environment developer. So now let's try to change this tag by the using developer 1 and go back to our configuration. Okay, and try to clear the screen, and again developer 1 we are in developer 1. What I'm going to do, I'm going to change this to okay, and save the configuration, okay, and then Terraform. You see here very closely, it will trying to acquire the state lock again, okay, and one changes is going to be applied, which is developer to prod. Tag is going to be changed, okay, environment tag, and it's deployed by the developer 1, and now developer 2 is going to be changed. So we have using the two different folder for developer 1 and developer 2, two different execution files. So it is sharing one Terraform file from the S3 bucket. That's how it is going to be implemented. Let's go back to the quickly on the S3 before deploying and check the now DynamoDB table, how the lock is populating. Let's go table again, the table, our table explorer, okay, modify is applied, and if we go back the terminal, we'll try to execute the changes what we want. Okay, so this is applying zero change, and let's see how it is going to be applied. Okay, just give the permission yes. Has been completed, apply has been completed, okay, and if we go on S3 bucket again, or like AWS, and check the EC2 instance first, whether the changes is applied or not, and go to EC2 instance, check the tags, okay. So now previously it was dev, now it is prod, okay. So this is how shared configuration remote state file can be used using the locking system to avoid the conflict and avoid the crash or duplicate execution accidents, okay. So let's go back and check the S3 bucket once again, tf state file, okay. See the versioning, yeah, so this is the same version, okay. Okay, this is how you can use this solution. So DynamoDB, a serverless service from the AWS, it's pretty much very good serverless service as the database tables. We can create that multiple tables as a database in the DynamoDB and use for your storing these kind of configurations, or like non-SQL data, or like objective data in the DynamoDB. So this is how all I want to show you, okay. Make sure you're destroying all the lab once you create it to avoid the changes, okay. And thank you for watching this video. Goodbye.